Okay, hello. Welcome again to another exciting moment here. And in this video, I'm going to be solving this question. Here we have payments of 500 US dollars are made at the end of each year for 10 years. Interest has a nominal rate of 8% convertible quarterly. So when you look at this question, you are going to see that payments of this amount, that's $500, are made at the end. So each year, at the end of each year for 10 years. So that simply tells you that that is an annuity immediate. Now, interest has a nominal rate of 8% convertible quarterly. Now, usually, whenever we have the interest rate given in as a nominal rate, we'll have to change it to an annual effective interest rate. And how do we go about that? Changing that to annual effective interest rate is going to be 1 plus I, and then we have this to be equal to 1 plus, we have the I with this notation here. Now, remember, it's quarterly. So since it's quarterly, so in a year, we have 4 quarters divided by 4 and raised to the power of 4. So the first thing to do is to convert the nominal interest rate to the annual effective interest rate. And having done that, then we can use that as the interest we are actually interested about. That's quite funny anyway. All right, so we have I to be equal to, this is going to be 1 plus, now, the nominal rate is 8%. So this is going to be 8% divided by 4. And this is 4 raised to the power of 4. We have here minus 1. Now, when you look at this, when I open this bracket and this 1 will move to the other side, it becomes minus 1. So just to conserve space, I'm going to have this to be 1.02, and that will be raised to the power of 4 minus 1. How did I get that done? 8% divided by 4 is 2%. So 1 plus 2%, that will be 1.02, right? Because 2% is 0.02. So 1 plus 0.02, that gives me 1.02 raised to the power of 4. And when I compute that using my calculator, 1.02 raised to the power of 4 minus 1. And that gives me 0.0824 I think I can pause there. So now this is same as saying if you want to put that in percentage, that's going to be 8.243, that's 3%, right? So I have the annual effective interest rate, so I'm going to use that to calculate the annuity immediate. Now, what is the present value? So the present value, the notation for that is A with the N here, and then I have my I here. So that is the notation for the present value of annuity immediate. So what I'm going to calculate now is going to be 500. So the present value is going to be 500 times this, which is going to be 10. And that's because I have n to be 10. You can see that for 10 years. And then my I, which is going to be this, and that's 8.243%. So I have this to be same as 500. And the formula for this is 1 minus v raised to the power of 10 divided by I, which is 8.243%. So I'm going to have that to be 8.243%. Good. So when I multiply this, this will actually give me, so well, I cannot decide to say, okay, fine, let me calculate what the V is. Remember, V is going to be 1 over 1 plus I. Now, what is I? I is this value. So I'm going to say 1 over 1.08243. That's what my V is. So this is, I'm gonna have this, and my V becomes 0.9238, and you can leave that with a 5 there. So that's the value of V. So you can see this, I'm going to raise it to the power of 10. That's raised to the power of 10. Then I'm going to subtract 8 from 1. Whatever I get, I'm going to subtract it from 1. That'll be 1 minus, that's my answer. Then I'm going to divide it with this. So I'm going to have 0.547. Yes, at the top here, 0.547. Then divided by this, which you can use this value actually. Yes, you can use this value. So divided by 0.088243. Now the whole of this is actually, let me have this 500 times, this is going to be 6.6372. Yeah, we also have some digits there, but I'm going to pause this. So this is times 500, and the present value of this payment, the payment of 500 at the end of each year for 10 years, is going to be, oops, let me have that here. With the dollar sign there, it's going to be 3,318.63. That's what I have there. That's to be 3. So I'm going to have 3 here. So this is going to be the present value of this payment. This payment that we made for 10 years at the end of each year for 10 years. Now, the next part of the question says, what is the accumulated value of this payment at the end of 10 years? So when you say accumulated value, it's simply telling you the future value of that payment now. So that's the future value. So this is going to be 500. And then I'm going to use the future value notation, which is S with the 10 here. And then I, which is 8.243%. And so this is going to be 500. Now, in some case, you can actually solve it this way, or better still, yeah, you can start to use this formula actually. Yeah, we can have this way to say, this is gonna be, I'm gonna put this way like this, and I have 1 plus I, which of course, let me put that somewhere with a different color. I think purple should do. So S and I is going to be as 1 plus I raised to the power of n minus 1 over I. So I can use this formula, or I can use this to say this is going to be 1 plus I, and I have this to be raised to the power of n dot a n I. Right. So I can have that value that way. So in this case now, I can decide to use any of this actually. So it works. Now you can see this. I have calculated this value, so that makes it easier for me. So I think I can do that. So this is going to be what I have here. So I can decide to put this value here so you can see this, because the future value is actually what I have here. So this is going to be, yeah, maybe I'm going to use a different color for that. I'm going to use green. Yeah, green. Okay, so this is my I is actually this value. So 1 plus this value is going to be 1.0824, and that's going to be raised to the power of n, which is 10. And then the present value factor of annuity immediate. And of course, you can see that the value is this. Remember, the whole of this. You can see this. So I'm just going to simply say this is 6.632726. Now, when I multiply what I have in there, I'm going to have already, this times this actually gives you this value. You can see that over here. This times this actually gives you this value. So I'm just going to multiply what I have here. Let's see. 0 times 1.08243 raised to the power of 10. And when I multiply that, I'm going to have 7,327.52. Yeah, this is common. Okay, so now I have fully solved this question. I have the present value to be this amount, and then I have the future value, which is the accumulated value of this payment at the end of 10 years. So this is going to be the accumulated value that's talking about. This is the accumulated value, while this is the present value of the future payment. Yep, that's it. So watch out for my next video. I'm going to drop in lots of videos on something like this. Thank you.